Assalamu alaikum, I'm Tarim Ishaq, and the topic I'm going to present is cross correlation of the microbiome to gut and respiratory health. The recent COVID-19 has raised several concerns, including the development of new tools for better identification of newly developing viruses and understanding the host microbiome relation. There are two terms, holobiont and virome. Holobiont, a tight symbiotic relationship between the host and microorganisms, is referred to as holobiont, while the viral species residing inside the human body as normal flora is termed as virome or human virosphere. There are almost 320 viral species residing inside the human body as normal part of the healthy microbiome. There's an important role of genomics in identifying more viruses. There are almost less than or equal to 109 virus-like particles per gram inside the human stools. More than 750,000 uncultivated viruses have been identified by next-generation sequencing, namely metagenomics and metatranscriptomics, which is 5 times the number of viruses sequenced from viral isolates. Viruses as gut microbiota. Phages make up 96.1% of the human gut viral populations, and 3.8% of the viruses are eukaryotic viruses, and only 0.1% are archaeoviruses. Importance of virome. So, the virome shapes the gastrointestinal immune system through a dynamic equilibrium with all microbial communities of the gut microbiome. And it also plays a key role in the regulation of gut homeostasis and inflammation. In particular, the virome continually stimulates low levels of host immune responses without causing symptoms. Based on the current knowledge of the virome host interactions, it is likely that variations within the systemic and local gut virome acting as commensal viruses helps to mold the immunological phenotype of the host. And this is the figure showing how the normal flora of human body is setting up a defense system again to protect it against the actual pathogenic species of different bacteria or viruses. The virome role in respiratory system's health. Basically, virome is not present at the time of birth in humans, but it develops during the first 2 years of life through continuous exposure to environmental stimuli. The upper respiratory tract is an open environment and it represents the main point of entry for pathogens that may cause an imbalance in the related microbiota. Indeed, in pediatric URT infections, disease development is associated with oral bacteria such as Prevotella and Leptotrechia species. While Corynebacterium and Dolosclinacidramulum species seem protective during the first year of life. Then this is a table showing alterations in bacteriome composition during respiratory and infectious respiratory diseases. There are several respiratory diseases like chronic rhinosinusitis, asthma, cystic fibrosis, idiopathic pulmonary fibrosis, bronchiectasis, lung cancer, and H1N1, COPD, influenza A virus, respiratory syncytial virus as RSV, and bronchiolitis, and SARS-CoV-2. So these different diseases are affecting the normal microbiota of your airways and also the gut. So there is increase in several bacterial species and decrease in several others. As you can see that some diseases like chronic rhinosinusitis, idiopathic pulmonary fibrosis, bronchiectasis, not only affecting the airways bacterium and are not causing any effect on the gut bacterium. While when we see at SARS-CoV-2, it is affecting both of these microbacteriomes. There is an increase in Burkhardt and Klebsiella pneumoniae inside the airways bacterium, while there is a significant decrease in Lactobacillus cerebrius. As we can see, the gut bacterium is widely affected. There is an increase in several number of species inside the gut bacterium, and several other different species have been decreased in their number inside the gut. And there are some other species which are increasing and decreasing because of the SARS-CoV-2 virus. In infants with bronchiectasis of the lower respiratory tract caused by respiratory syncytial virus, 5 nasopharyngeal microbiota clusters enrichment have been recorded. These include Haemophilus influenza, Streptococcus, Corynebacterium, Moraxella, and Staphylococcus aureus. The lung microbiome may be altered by external factors and infectious agents and has been linked to lung disease progression, phenotype, and severity, including lung cancer. The LM lung microbiome protects against respiratory infections induced by Streptococcus pneumoniae and Klebsiella pneumoniae by triggering the pulmonary production of granulocyte macrophage colony stimulating factor GM, CSF, via NOD2 and interleukin 17 stimulation. The role of airway and gut virome in respiratory diseases. Although most respiratory viruses, including RSV, influenza virus, and rhinovirus, have been widely studied and their pathogenic effects have also been well documented, clinical metagenomics are opening new landscapes for studying novel respiratory diseases, novel respiratory viruses like SARS-CoV-2 and their effects on the airway and gut bacterium. Within the eukaryotic virome, the Anneliviridae family represents approximately 70% of the entire virome of the plasma and bronchoalveolar lavage fluid in patients receiving standard antiviral prophylaxis, heart and lung transplants, and immunosuppression after surgery. Because of this statement, we get an idea as if Anneliviridae is some sort of an opportunistic pathogen. However, members of the Anneliviridae are not considered to be pathogenic for humans. One preliminary study indicated significant changes in the gut bacteriome, which were associated with the severity of this infection. Recently, a shotgun metagenomics study demonstrated that the gut bacterium composition was significantly altered in patients with COVID-19 compared with non-COVID-19 patients. In COVID-19 patients compared with subjects with community-acquired pneumonia and controls, this process was also characterized by an increase in Candida albicans, Candida aureus, Aspergillus flavus, and Aspergillus niger. So these are the few, you can say, fungal species which are also being affected because of the COVID-19 infection inside the human body. These 4 species were the latest detected in few COVID-19 patients even after viral clearance. So I'm going to conclude this topic here. The metatranscriptomics and metabolomics are considered to help us in understanding COVID-19 disease phenotypes more clearly, ratifying the definitive translation of big data-based microbiomics to COVID-19 enhanced diagnostics and clinics. So that was all. Thank you so much for listening.